In our last lesson, we talked about functions and how they're special. It's a special connection between inputs and outputs. We said every input or every x value has a unique output or y value. Okay, we talked about the idea of people and birthdays, how one person must have a unique birthday. A person or an input cannot have two birthdays. They must have one unique birthday. We need to talk about how in math we show functions, and one of the ways we do that is with function notation. So you will see things in this lesson where it says f of x. That's how we read this. Okay, this is read as f of x. And that's function notation. And here's what we have. You will have some function. Maybe it will be f of x equals, say, the square root of x. Or instead of the square root of x, maybe you'll see something like f of x equals x plus 5 squared minus 7. Or maybe you will see f of the absolute value of x minus 9. You'll see something. That's what these dot dot dots are trying to show you here. But there will be an x in there. Okay? That x here is your input. That's where you're going to input values for x or put in values for x. And whatever it's going into, whether it's going into the square root, whether it's going into the absolute value, it's going to come out. So this piece together, the entire f of x piece, is your output. In the past, you might have seen things like y equals the square root of x. Now, instead of y, we're going to say f of x equals the square root of x. So really, your f of x and your y, they're both outputs. You put in a value for x, you get out a value. So let's practice this a little bit. We're going to evaluate functions. And when we say evaluate, what we mean is this. We mean to substitute a value for x and then simplify, remember using PEMDAS and all that, simplify to obtain the y value or the output. So for example, algebraically evaluate each function for when x equals 3 and for when x equals negative 4. So here's how we do this. This one says f of x equals opposite of x squared plus 1. So we copy down the function exactly as it is, but notice I'm leaving blanks wherever there was an x. Okay? Where these blanks are, that's where you input the value. So for this, x equals 3, we'll say f of 3. And we put a 3 wherever there was an x. This doesn't change. This stays the same. We just say f of 3 equals, we simplify this. 3 squared would be 9, and this has a negative on the outside, plus 1. Negative 9 plus 1 is negative 8. So f of 3 equals negative 8. Now, remember, this was what you input, right? You put in a 3 to the function, and the output, this guy, this is what you got out, was negative 8. So this whole thing is your output. The output is equal to negative 8 when you input a 3. This is why we like function notation. It shows us both numbers at the same time. It shows you the input or the x value, and it shows you the output or the y value. We also need to do x equals negative 4 for this one, and looks like I ran out of room for this one. Let's write tiny. Let's see if we can fit this guy in. F of space negative squared plus 1, and we put in a negative 4, negative 4. Negative 4 squared is 16. This negative is still out front, plus 1. Negative 16 plus 1 is negative 15. So the best way to write this one would be to say that f of negative 4 equals negative 15. That would be to evaluate the function. And so would this. Those are both ways to evaluate f of x. All right, let's go ahead and let's do these ones over here on this side. So g of x, g of, leave a blank, absolute value of 5 times blank, and then input the 3. So g of 3. 5 times 3 is 15. Absolute value of 15 is 15. So g of 3 equals 15. That's our answer. Do the same thing for negative 4. G of absolute value of 5, parentheses, input a negative 4, negative 4. 5 times negative 4 is a negative 20, but it's inside an absolute value. So we really get positive 20. G of negative 4, I'm going to put it on this side here. G of negative 4 equals 20. And then for our last one, all right, let's see if I can fit it on the screen. Here we go. All right, h of 9, 1 minus parentheses, slip in a 3. So h of 3 equals 9, divided by 1 minus 3 is negative 2. So we get negative 9 halves. So that's our answer there. H of 3 equals negative 9 halves. Let's do h of the negative 4. So we get 9 over 1 minus negative 4, negative 4. Remember that when you have a negative times a negative like this, they become positives. So we get 9 over 5. So h of negative 4 equals 9 fifths. Okay? And again, it's so nice. We love this because it shows us all of our inputs. These are all the numbers we put into things. All of these. Those are all the input numbers. And then it also shows us at the same time what we got out. We got out a 15 when g of 3. We got out a negative 9 halves. We're going to come back to this idea in a second of inputs and outputs. Let's take a look at evaluating a function graphically. Okay. So we see two functions here. We see the blue function, or on your paper it should be a solid line. This is the f of x function here. And then we also see the g of x function, or the dotted line on your paper. So for f of 4, remember this value right here is the input or the x value. So look for x4. Here's x equals 4. What is the y value of f of x? So look up on your graph. Here it is. There's the point. When x is 4, y is 6. So f of 4 equals 6. Try it for f of negative 5. Here's negative 5. There's that point. When f of negative 5, we get 7. F of negative 5 is 7. Let's look down at your g of x graph. What about g of 0? So here's 0. X is 0. So our y is negative 5. G of 2. Here's 2. There's the point. So g of 2 is negative 3. Let's flip back to f here. F of 0. So when x is 0, there it is. So it's 6. And another one for g when g is negative 8. So negative 8. Here's x, negative 8, negative 4. Okay. So everything in this first column, these are all the input values. And these are all your output values over here. Okay. Another way to say this is that these ones, those highlighted numbers there, those are your x values, or remember the other word we said for that is they're the domain values. And these ones that came out of the function or came out of the graph, these are your outputs, your y values, or we call them the range values. All those words go together there. All right, so we are going to graph some functions, and then once we've graphed them, we're going to give the domain and range of the functions. We're going to give the x values and the y values. So we're going to input these values over here, and we're going to get outputs on this side of the graph. So f, leave a space, equals -4 space plus 3, and go ahead and slip in your -2, and then simplify. -4 times -2 is a +8 plus 3. +8 plus 3 is 11. That's our output value. Do the same thing all the way down. Okay. So these number pairs are your outputs. So f of -2 is 11, f of -1 is 7, f of 0 is 3, f of 1 is -1, f of 2 is -5. So we're going to plot these points. And for this one, we have some pretty high numbers in here, 11, 7, 2, etc. So we have two choices. One, we can make 11 way up at the top of the page, or we could go by twos. Let's see if I can go by twos for this one. So here's 2, 4, 6, 8. There's 10. 2, 4, 6, 8, 10. So this is -10. And this is -10. So -2 comma 11. So this is -2. And 11 would be up here. -1 comma 7. Remember, -1 is going to fall halfway now. 2, 4, 6, and there's 7. So -1 comma 7. 0 comma 3. 1 comma -1. And 2 comma -5. Okay. So there's our line. And remember, these dots here, we could plug in any numbers, not just these 5s, right? We could keep plugging in tons and tons of numbers. So this is actually the line through these points. Whoa, goofy line. Your line is going to be much straighter, much more beautiful than my line, I'm sure. Oof. Rough day. Okay, that is supposed to be a straight line, if you can imagine that. And then that is our function. This is the function f of x, which is the line -4x plus 3. So we're just calling it f of x right there. Now let's talk about the domain and the range. We know that our domain are the inputs. So yes, the domain could include things like -2, -1, 0, 1, and 2. Those are all in our domain, to be sure. But again, remember we said we could plug in any number, right? I could plug in a 22. I could plug in 1.375. I could plug in any number I want here and get something out. So as long as we can plug in any number on this x-axis, think about it. Like we could even plug in -10. It's going to be off our chart, but we could plug it in. We could get a value way up there. I could plug in something halfway or 2/3 of the way. I could plug in anything for any single dot on this picture. So if we can use anything, think about it. We're going from -infinity, really, all the way up to infinity. Any dot on this line, any x value could be plugged in and we could get something out. So to go from -infinity to infinity, we'll say the domain is -infinity to infinity. We use interval notation to talk about it. So it's more than just these numbers. It's any number could work. Now to talk about range, this time we're talking about values coming out. Things like 11, 7, 3, -1, -5. Those are all range values. But we could get more than that, right? There's all these other little dots on this line. There's a dot for almost every y value you could think of, not just the ones in our chart, right? We could have y values that are all the way down here at -10. There's a dot. -15. There's a dot. We could keep going off the chart. In fact, again, we could go down all the way to -infinity and think about going up. It reaches all the way up. So we could go all the way up to +infinity. It spans the whole graph. So our range also goes from -infinity to infinity. This time it's going on the y-axis, but it's still all possible numbers. Let's look at another one together. Same deal. We're going to fill in our chart. We're going to get our input values for x. We're going to get output values for y, or in this case for j of x. We're going to graph them and then talk about domain and range. Okay. So, for these ones here, think about what we know about square roots. We know that we can have something like the square root of 2, and we can have 5, but we also know that's not a perfect square number. So for this one, we'd have to use our calculators, and the calculator tells us that the square root of 2 is about 1.414. So 1.414 plus 5 is 6.414. About. There's more decimals, dot, 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 that keep going, but we're only going to use that many. Square root of 1 is just 1, so 1 plus 5 is 6. Square root of 0 is 0, so 0 plus 5 is 5. Now when we get to this one, this is weird, right? Look at this. Square root of -1. We remember back from Algebra 1 that you can't have negatives under your square root. It's not possible. So this is a not possible number, and you can't add 5 to a not possible. Like if I say 5 plus 3, you say, oh yes, 5 plus 3 is 8. But how do you say 5 plus not possible? So this answer is a not possible answer. Same thing for this one. It's a not possible. And if it's not possible, that means we're just not going to graph it. We're going to leave it empty. Think back to your inequalities. We said if you ever get this, it's a no solution, you don't graph. So let's plug in what we do know. We know 0, 5. So make this 5, 5, -5, -5, y, and x. 0, 5. That's our first one. We know 1, 6. So this one's going to be up a little bit more here at 6. We know 2, 6.414. So a little higher than 6. That's not many points. I think I need to see more before I see the shape. So let's take and let's do a 4, and let's go ahead and let's do a 9. And you notice we can choose any number for our inputs, right? You might notice why I chose these. Yeah, because these ones are nice numbers. When I take the square root of 4 and the square root of 9, it's going to be good numbers. Square root of 4 is 2. 2 plus 5 is 7. Square root of 9 is 3. 3 plus 5 is 8. We need to extend our graph a little bit here. That's 5, 6, 7, 8, 9, 10. Make it nice and high. So 4, 7. 4, 6, 7. There he is. 9, so I have to make this one come out too. 6, 7, 8, 9. 9, 8. There he is. So this graph, if we connect the dots, it's here. And it's kind of messy because it's by hand, but he should have a little bit of a curve to him. So a little bit of a curve going on here. Now, what about graphing over here on this side? Well, look at the -1, right? That was the negative under the square root, which gave us a no solution, so I'm not going to put a dot. There's nothing I can graph here. In fact, any of these negative numbers, if I plug in even a -1/2, it's still a negative in a square root, and I can't have that. Even -0.00001, even the teeniest little negative, I can't have a negative, so there's nothing to graph on this side of my axis. This is it. He starts at 0, and he moves up through the positive numbers. Now, when we talk about domain and range, what is the domain and range for this graph? Well, first of all, think about what types of numbers we could put in, right? We said we could put in anything that was positive. Anything from 0 upwards was fair game. So my domain is going to go from 0 all the way up to positive infinity. And I can include 0, right? I actually have a filled in dot at 0, so he gets a bracket. Now for range, what types of numbers come out? I can't include no solutions. When did I start getting real numbers? I didn't get a real number until 5. That's because I plugged in 0. And again, look at my graph. That's the first time I see anything shaded in the up or down region. So from 5, and then all of a sudden I got 6 and 6.4 and 7, I started getting all sorts of dots up through here. So my range starts at 5, and I get to include it because it's closed circle. And then moving up that axis, I could have any of these numbers might show up on that graph, so all the way up to infinity. So this interval notation comes in for that as well, too. Maybe another way to help you highlight this is that these x values, what did I use? I went from 0 all the way up to infinity, right? That's what this is, 0 up to infinity. And then for my range, I didn't start until 5, and then I could keep going 5 all the way up to infinity. That's what these numbers are here. And it's just looking at the shape of my graph. What numbers was I allowed to use? I did not use any negatives on the x-axis, so no negatives in my domain. And I couldn't use anything beneath a 5 on my y-axis, so nothing beneath a 5 in my range. So those are two big important ideas for us today, domain and range, and also this idea of a function notation. J of -2 equals, and then your output, okay, inputs and outputs.